Everything in this series so far describes a machine that does one thing. Text goes in, text comes out. It is a brain in a jar, a brilliant one, but sealed off, with no eyes, no hands, no way to affect anything. It cannot check today's weather, run a calculation it is unsure of, or send a single email. And yet, you keep hearing about AI that books flights, fixes code, and works through a task on its own for 20 minutes. So, what did they add to a brain in a jar to do that? The answer is smaller than you think, and once you see it, agents stop being magic and start being obvious. A glowing brain floating inside a sealed glass jar labeled language model, with no arms and no eyes, a thought bubble above it reading, "I cannot touch anything." Let us start with what the brain is missing. The model cannot look up today's weather, but we can write a small, ordinary program that fetches the weather, the kind of thing that has existed for decades. Now here is the move that changes everything. We tell the model in plain text that this program exists, roughly like this. There is a tool called Get Weather. If you want to use it, stop writing and output the exact phrase, "Get Weather," followed by a city. That description is called a tool, and we can hand the model a whole toolbox of them. Search the web, run this code, send an email, query the database. The brain in the jar now beside an open toolbox, each tool a labeled card, get weather, search web, run code, send email, query database. Captioned, tools are just programs we describe to it. But wait. The model still only outputs text. It cannot run a program. It can only write the words, get weather. So who runs it? This is the piece everyone misses. Around the model, we wrap a second, ordinary program, the part that truly deserves the name agent. The agent watches what the model writes. Most of the time, it is just words passed straight through to you. But the instant the model writes, "Get weather London," the agent springs into action. It intercepts that phrase, runs the real weather program, gets back the answer, say 12 degrees and raining, and pastes that result back to the model as new text. The model wanted a fact it did not have, and the agent fetched it. A wrapper box labeled agent drawn around the brain jar, catching a slip of paper reading Get Weather London, running a small gear labeled Weather Program, and handing back a note reading 12 degrees, raining. Notice what just happened because it is the whole idea. The model did not gain a new ability. It still only writes text. All we did was agree on a convention. If you write a tool's name, something outside, you will run it and hand back the result. The intelligence decides what to do. The wrapper does it. The model is a genius with no hands, and the agent is the assistant beside it who presses the buttons and reports back. Now for the part that turns a helper into something that feels alive. So far, this is one step. Ask, fetch, answer. But real tasks are not one step, so we do not run the model once, we run it in a loop. The model looks at the goal and writes a thought. What should I do first? Then it picks a tool. The agent runs it and feeds the result back. The model reads that result and thinks again. What next? Around and around. Think, act, observe. Think, act, observe. A machine that watches the consequences of its own actions and decides its next move based on what it sees. Let's watch it work. Book a table for 4 somewhere near the office on Friday. Pause the video and think about how many separate actions a human does for that. Here's the loop. The model thinks, I need the office address, and calls a tool to look it up. It observes the address. It thinks, now find restaurants nearby, and searches. It observes a list. It thinks, check which have space for 4 on Friday, and calls a booking tool. It observes that 1 is full, so it tries the next. No human wrote that sequence. The model generated each step only after seeing how the last one turned out. That capacity to adapt to results it could not predict in advance is what makes something an agent rather than a script.
And this reframes something from earlier. Remember how the model was hopeless at large arithmetic because it approximates instead of calculates? An agent fixes that in the most sensible way.
It does not try harder. It writes some code, hands it to a tool that actually runs it, reads the real answer, and continues. The same trick handles frozen knowledge. It cannot know today's news, so it searches the web and reads the result. Even the document questions from last episode are just a tool the agent can call. The brain stopped needing to know everything because it learned to go and find out. Now, the honest part. Because an agent is far more fragile than a chatbot. A single wrong answer is one mistake, but in a loop, a wrong step becomes the starting point for the next, so errors compound. Take a wrong turn early, and the agent can confidently march 10 steps deeper into nonsense. It can loop forever, repeating the same failed action. And giving a text predictor real hands, the power to spend money, send messages, delete files, is exactly as risky as it sounds. This is why serious agents run with strict limits, and why a human is often asked to approve the truly consequential actions. And there is a deeper limit. An agent is only as capable as the thinking of the model at its center. The loop gives it hands, but the model still decides every move. If it chooses the wrong tool or misreads a result, no amount of looping saves it. Hands are not judgment. This is why the quality of that core reasoning matters so much, and it is exactly where the next episode goes. So here is the big picture. A language model is a brain in a jar that can only produce text. We describe tools to it in plain language, real programs it calls by simply writing their names. A wrapper program, the agent, watches for those names, runs the real tool, and feeds the result back. Put that in a loop, think, act, observe, and the model can pursue a goal across many steps, adapting to what it finds. It did not become smarter, it got a loop and a pair of hands. But we just leaned on something heavily. Every one of those tools had to be described to the model and wired up by hand, one at a time. When every company builds its tools differently, connecting a model to the real world becomes a tangle of custom wiring. What if there were a single universal standard for plugging any tool into any model? There is. It is one of the most important recent developments in the field, and that is next time.